Okay, so a growing number, well, first off, this is 2001, question 5, and it's our sixth problem for the day. And a growing number of employers are trying to hold down the costs that they pay for medical insurance for their employees. As part of this effort, many medical insurance companies are now requiring clients to use generic brand medicines when filling prescriptions. An independent consumer advocacy group wanted to determine if there was a difference in milligrams in the amount of active ingredient between a certain name brand drug and its generic counterpart. Once again, difference is probably an important word. Pharmacies may store drugs under different conditions. Therefore, the consumer group randomly selected 10 different pharmacies in a large city and filled 2 prescriptions at each of these pharmacies, one for the name brand and the other for the generic brand of the drug. The consumer group's laboratory then tested a randomly selected pill from each prescription to determine the amount of active ingredient in the pill. The results are given in the table below. Based on these results, what should the consumer group's laboratory report about the difference in active ingredients in the 2 brands of pills? Give appropriate statistical evidence to support your response. Okay, so first off, there's a list of data. If they give you a list of data, which I don't think they will on this test, but if they do, you're almost assured that it's going to be some sort of test of means. All right. So in this case, I was like, okay, I have two lists of data. So it could be either a 2-sample test for means, or it could be a paired, looking for a paired difference. So the next thing I look and go, are the data lists the same? And because if the data lists are different, it can't be paired. Well, the data lists are the same length, so it's possible that it's paired. It still could be 2 samples. Well, then I need to sit there and go, was something tested twice? And here's my clue. I have a 3rd row. That 3rd row lets me know that the pharmacy essentially was tested twice. How do they handle the name brand versus generic? Name brand versus generic for each pharmacy. All right. And because the pharmacy was tested twice, essentially, because the pharmacy was tested twice, we're going, you know what, we can do a match pairs. Technically, we always like to do a match pairs when possible, because match pairs or a paired test controls for differences in between. In other words, it controls for more variation than most any other type of test that we run. So my null hypothesis is there's no difference, and my alternative, and my alternative is the difference is not equal to 0. It's something other than 0. I don't know which direction. I need to define that. UD equals a true population mean difference in active ingredient, name brand minus generic. It is absolutely critical for this particular test that you specify which way it is, all right, which order you do it, all right? So then we have conditions, random sample, and once again, if you would swap the order, that's fine as long as you run the entire test that way. Unless I tell you specifically, you can choose the order you want, just make sure you're consistent with it. So conditions, random sample of 10 pharmacies, they gave us that. 10 divided by 0.1, there are more than 100 pharmacies selling these drugs. All right. The next thing, I need a box plot of differences. Well, wait a second. I'm checking for normality. So to check for normality, it's one of 3 things. The underlying sample is normal. They didn't tell us that. My sample size is 30 or greater. I don't have a sample of 30. I have a sample of 10. So since I have a sample of 10, I need to go ahead and check to see if the data is reasonable to assume that it's normal. In other words, looking for no outliers or extreme skewness. So I entered all my data into stat edit. And then I went to top of L3 and I went second 1 minus second 2. And I got all my differences. So there's a list of my differences, and all I did was I went to the top and went L1 minus L2. Then I went second stat plot, pressed enter, and I selected the box plot that showed outliers because I want to show that. The list, my data is the list of differences. That's an L3, so second 3. And then I press zoom 9. And fortunately, when I look at this, it's like no extreme skewness and no outliers. Because I don't have extreme skewness and I don't have extreme outliers, it's okay to proceed. It's okay to say it's reasonably normal. Please don't forget you can use the trace button to get the values, all right? Also, if you don't want to include the scale like I did, I included the scale, but if you don't want to do that, make sure you kind of make the picture look kind of like what it has on your calculator. Label your minimum at -1, Q4 at 4, the median at 6, Q3 at 9, and the max at 16. And then make sure that you label that what your X scale is. In our case, it's just the differences. All right. So make sure you do that. I honestly think I don't think they'll have you input data. On the other hand, that's a good way for them to test to see if you know how to draw some sort of box plot or histogram, etc. So it would be a way for them to test something else. All right, so my formula, it's basically the same formula as a t-test. The t-test of one sample t is t equals x bar minus mu s divided by the square root of n. The only difference is I dropped some d's on it. That's all I did. Okay? Now, because I have in my alternative a not equal, I need to multiply my probability times 2. So I went stat test t-test, and I'm going to go ahead and run this thing. Well, my claim is that there was no difference, and I can go ahead and use my data because I have a list of it. My list is an L3. Frequency is 1. My alternative was not equal. And I can ask to calculate it, and it's 3.957. Make sure you're multiplying by 2 because of the not equal. And then it gives me a probability of 0.003. Well, that's a pretty small p-value. And so with a p-value of 0.003, it's less than alpha, we're going to reject the null. So our p-value is 0.0033. We reject the null. There's sufficient evidence that alpha equal 0.05 to suggest that the true population mean difference in active ingredients, name brand minus generic, is not the same. Technically, I probably should have made the comment at the bottom in common terms. There appears to be a difference in active ingredient. Okay, there appears to be a difference in active ingredient. That would be a safe comment to add at the very, very end. All right. My control bar.